Hello. Hello, hello. I am finally back for more Advent of Code, which is not very much Advent of Code. Last time we got stuck on 24, day 24, part 2, so we need to finish that, and then we have one more. Okay. I didn't really think about how to solve the day 24, part 2 much, but I do have an idea. So to remind myself, we just needed to find a position and velocity for the stone to throw so that it will hit all the other stones that have their own positions and velocities, and this all in 3D. So let me open the code. Let me open the code. So the in order to solve thing like that, in order for two things to be colliding, we have figured out that it is an equation like this: the cross product of the vector of the relative position multiplied by the relative velocity should be equal to 0. What does this actually mean? This actually makes like a lot of sense, because what this means is that so our relative position means that I need to hit this point from this point, right? So I need to go this way, which means that my velocity should be parallel to this line. So that's what cross product equals 0 actually means. The only extra thing that I can add to this, though, the only extra thing is that I need to hit it in the future. And in order to hit this in the future, I can also take the dot product of these two vectors and figure out that it is more than 0. But I'm not sure if we need extra thing like that. So in order to solve this set of equations like this, we have 300 stones that we need to hit. So in order to convert 300 equations into one, we take the length of the cross products and we add them together, and we say that they are equal to 0, and that is the equation which would make all of them be equal to 0. But I think that the problem with this is that when trying to like hit all 300 at once, it is a little bit too hard. The function that we're trying to minimize is a little bit too chaotic. We're trying to solve it, by the way, using the RNG descent. Maybe with a proper gradient descent it would be working nicely, but my current idea is just to continue doing it exactly like I was doing before, using some RNG and figuring out if a function in this point is like less than in the current point, then we update over there, and then we like take a bunch of points from a radius of a current point. That's the entire solution that we have right now. The only difference is that I would not be trying to hit all 300 stones. Instead, I will only be trying to hit like 3. Because if I had hit 3, then I already have a solution, and I just need to check that we're hitting all the other things. So yeah. How about we do hailstones, iterate, and then over here, the only thing that I'm going to add is just take 3. That's the only difference. Let me see. Cargo, run, part 2. Example. Wait, it doesn't work. If I don't take 2, then, for example, I actually am finding the zeros. Wait, so is this actually the bad thing to do? Is this actually the bad thing to do? Also, when calculating the cross product, I might just I'm adding up the square lengths. Why am I, if I'm taking 3 and only trying to hit 3, why is it harder? Because it should be the same. This doesn't really make much sense to me. It's an easier equation to solve when we're only trying to hit 3 stones. Interesting. In case I fail to solve this in a short time, then I will go to day 25, and then I might come back to this one and see, maybe look up the solution. This doesn't really make much sense to me. If it's a simple, like if I do 1, then the function will for sure. Wait. Yeah. If I just take 1, then for sure I will find a 0. No. Why am I not finding a 0 here? I just am trying to hit 1 stone here. It means that my RNG descent is probably not the best thing. Interesting. Interesting. If I just try to hit 1 stone, why am I unable to find the solution? Because technically, I definitely should be able to. I definitely should be able to. I'm running. Into big numbers or something. Let me debug me and f me. What is the solution that I'm finding? What is the solution that I'm finding? This is my position. This is my velocities that I'm actually finding. Before rounding and after rounding. Maybe it's because I'm rounding the things, because I'm trying to find the integers. But no, before rounding, the function is also not equal to 0 exactly. Or not exactly equal to 0. But we stop when it's less than 0.1. So over here it's less than 0.1 actually. So maybe it is close enough. But when I'm rounding the things, we stop being that close. Okay. So maybe because the amount of different solutions when I'm just taking one is too big. Let's take 5. Now it is 0. Look at this. Now it is 0. Okay. And then I do just part 2 instead of example. And I still cannot do it. Okay. Here is another improvement that I'm going to try. Right now I'm searching in a radius. Let me see my RNG descent. Yeah. This is our initial guess. And the radius is always starting with 1,000. But I think that might be too small of a radius. Let me do radius is going to be like the same. So for every single component, it basically means that I'm defining, I can do different radius on different coordinates. right? So it's not negative radius to radius, it's negative radius I until radius I, like this. While radius iterate copied max radius iterate max. We just then cannot do max because it's not ORed. So we do max by std f64 total CMP. No, f64 total CMP. Yes, this is what I want. This is what I want. I will need to copy it though for that to work, right? And then unwrap. So this will give me the maximum. So while the radius on any coordinate is more than 0.1, I'm going to continue the loops. And over here we do for 4x in radius. We multiply every component by 0.9. Sure. Okay. So over here, hmm. Over here, let me see. I will need to find like the range of the velocities or something. I'm already finding the range here. Trying to find the min and max. Find range. Find range for the hailstones. And then F from array into I64. This will give me the range. Range like this. Let's see. Hailstones, iterate, app, f, min, until, hailstones, iterate, app, f, max, unwrap. Unwrap. Like this. Range is std ops range. Okay, so over here the original coordinate is we generate for the range hailstones for stone position I, right? Okay. Let's see. Let range x, range y, range z is fn find range hailstones stone position I So range end minus range start. So maximum minus minimum is going to be the radius, basically. So I'm going to find this for the positions and for the velocities, right? So my initial radius will be radius x, radius y, radius z, radius for velocity x, velocity y, and velocity z, like this. All right. Is this going to make it better? Use of moved value. I have found some zeros. I have found a zero. After rounding, by the way. Before rounding, I'm not finding a zero, but after rounding, I am. Okay. Now the question is this actually the solution to this problem? Hold on. It looks like I am having some success after all. Without doing the proper math, was doing the programmatic approach using RNG, basically. Mostly. I don't think this can be counted as math. All right. Okay. Let me do this here. We are doing the rounding, and then after the rounding, I'm also going to convert this to integer. All right. So now that I'm converting this to integer, I want to check that I'm actually hitting all the things, right? So for stone and hailstones, I just need to check if we actually hit, right? This is a loop, by the way, which does find some random solutions basically every time, right? Yeah. But actually, the answer is true. So if it's actually the answer, then we break from the loop and we say that we find the answer as, I think, the sum of x, y, and z, right? Add up the x, y, z coordinates of that initial position. So me x plus me y plus me z. Me dot position x, y, z, print out the answer. Now I just need to like check it though that we're actually doing it here. Ooh, found the answer. If this happened. Okay. So yeah, we just need to find that and figure out that the cross product is actually equal to 0. And like I said, we should it should happen in the future. Check hits in future ray and line is this, returns a boolean. There you go. So first of all, I check if the cross product of ray position minus line position and ray velocity. Well, let's see. Relative position is so I need to hit the line, right? This is stone. Let's call this stone. Relative position is stone position minus ray position. This is our relative position, and relative velocity is stone velocity minus ray velocity. No, ray velocity minus stone velocity, because this is our velocity relative to the other one, and this is the relative position of the target, relative target position. that we're trying to hit, basically. So we need to make sure that we are going towards the target, which means that the cross product of the relative target with relative velocity should be equal to 0. So if this is not equal to 0, then we return false. And then also we need to make sure that we are going towards and not backwards, so it happens in the future. So the dot product of the same things should be more than 0, more than or equal than 0. So this is the thing. This should be equal to 0, and this should be more than or equal than 0. This is Fn. So cross product gives you a vec. So there you go. So we need to check that that me hits the stone in the future, and also the stone hits me in the future. Similarly, we just swap the things. So if either of these is false, then we actually, the answer, we set it to false, and we break the loop. There you go. Okay, let's see if I actually am finding the answer here. I did find the answer. All right. Let's see if this is the correct solution, the correct answer, though. It is. All right, there you go. No math is actually required to solve this. You can do it as a programmer. I was lied to. All right. I would like to see the actual math solution. What did they do there? So the problem, why it was hard, because this equation that we're trying to solve, it's not a linear equation. I'm not good with any equations other than linear. This is a bilinear equation, and you need to solve the set of bilinear equations, right? Math solution over there. Confirm your account settings. That was just for GitHub, because I did not. All right, whatever. There is no secrets here. There's no secrets here, right? Nothing is leaked. Okay, confirm. Oh, you did it in Rust too? Okay. Warn Clippy Pedantic. Nice. So 2D intersection, it seems like... Oh, I see. You're trying to solve it for the first 3, and you are doing it using denominators. You could have used the, I don't know, in an algebra. So this looks like the determinant of the matrix, right? I would not be writing this by hand, but okay. But what exactly is the equation that you're trying to solve here? You don't have them in the comments. What is the equation that you're solving by doing this? Because this looks like the solution to a set of linear equations, but the equations that we have, they are not linear, is the thing. Or are they? No, they are not. Unless, what are you trying to solve it for? What is your unknowns? Not the velocity and position, but something else? Just time is your, so position and time. Time 1, time 2. So you are trying to solve it for the 2 times. Times for hitting stone 1 and stone 2, and then projecting backwards to find the launch position. But you are trying to hit 3 stones. Don't you need to figure out the time to hit the 3rd stone too? Or if you know time 1 and time 2, then in order to hit the third one, that like hitting the third one gives you the equation, I guess. So yeah, so that means that you only have 2 unknowns in this case, right? Equation requires 3 stones to get a constraint solution, but then I needed 2 times to find the answer. Yeah, I would like to see the actual equation that you're trying to solve here, not the solution to the equation. Well, let me think about it. So the unknown, so like I was just making my unknowns the actual like thing that I want, the position and velocity, which makes it a bilinear. But if you do it with time, then what does it mean? Well, I guess it is the 3 equations. So the equation is basically that you're having is something like basically the position for the hailstone number this plus position plus velocity this multiplied by time to hit this is equal to the unknown position plus velocity multiplied by time, right? So the unknown is the ti and the t. So, well, this is the same. This is the same time to hit the I. Right? So for every single hailstone, it gives you the unknown. Yeah, this does look like a linear equation. Wait, no. Hold on. The velocity, hold on. The time is unknown, and then the velocity that you have here is unknown. So this is still a bilinear equation. Well, what? You're multiplying the unknown by the unknown here. So the equation to hitting stone 1 at time 1, stone 2 and times 2, stone 3 and times 3. Yes, so like, so I is here from 1 to 3, basically. 3 equations for 3 unknowns. But isn't the... Wait, hold on. Hold on. The position and velocity over here is still unknowns for me. How do you make the equation without the position and velocity then? If you just have the time. This is the equation with the velocity. I guess using 3, you can like, I don't know, do something with this? I don't know. Like, what's the actual equation that you have? This is what I was trying to do last time, and it was so hard. Do you want me to write a bot for the Tetris here, or what? What is this? You should explain this better in the description. I think that's what it is, but you need to explain it here. Your login system doesn't work. Unable to process requests due to initial state. This may happen if browser session storage is inaccessible or accidentally cleared. Alright, I tried though. Tried. Maybe try to fix this. You started with 9 equations. Firefox has a bug. Disable advanced tracking. I think that's not a bug in Firefox. That's like, why would you require advanced tracking to be disabled for logging in to your website? That sounds like a bug in your thing. You're trying to like track me or what? Started with 9 equations. Through manipulating the equation, you managed to zero out the coefficients for x, y, z, dx, dy, dz, and were left 3 equations, time 1, time 2, and time 3. It's a bit hard to explain. Yeah, I guess. So you actually like do the math there. You like do the substitution and things like that. Is this the way, right? Just try to like represent the x, y, z, dx, dy, dz using time 1, time 2, time 3 instead. It's a bug in Firebase UI. Alright, let me do as a guest. Sure. Watch this event on YouTube. Amazing. Waiting for players. What does it mean? What does it mean? Function, score function. What is this? This is simple implementation showcasing the API. Improve it on your own. And you only have JavaScript. But I can play with using my hands. All right. How do I rotate things here? How do I rotate things? QE apparently instead of up. Okay, you made a Tetris, and it's multiplayer, right? And then something happened in the bottom. Is this because this is me playing right now, right? This is me on the left. This is someone, and this is built-in AI. Someone is me, basically, right? This is what it seems. And now I have lost. To the built-in AI. You played well and got one Christmas decoration. What is one Christmas decoration? Leaderboard. Okay, I think you need to do a little bit more of the explanation of what is happening where and like how do you get into like writing code there and everything. Even me finding the link in the description requires a little bit of non-trivial actions from the one who finds that stream on the YouTube, I guess. Link is in chat and pinned message. I didn't see the chat for some reason. And like I said, it should not be just a link. You should explain what's happening here. Make a description, make a text. Not just a link. So like this is where you can play yourself on the stream, you know? Maybe. I mean, I figured it out, but I think a lot of people would not even try figuring it out. It's simple, you just either play Tetris or write Tetris bot. There you go, just put this in the description. There is no text saying this in the description. Just put your message that you just written in the Twitch chat into the description of your stream there. All right. Day 24 though has been solved without using math. Easy. Let's Let's finish the advent of code and go. Day 24, actually easy. And let's solve the last day of the advent of code, which is day 25. Is this one hard or not? Day 25, Snowverload. Still somehow without snow, you go to the last place you haven't checked, the center of Snow Island, directly below the waterfall. Here, someone has clearly been trying to fix the problem. Scattered everywhere are hundreds of weather machines, almanacs, communication modules, hoof prints, machine parts, mirrors, lenses, and so on. Somehow everything has been wired together into a massive snow-producing apparatus, but nothing seems to be running. You check a tiny screen on one of the communication modules, error 2023. It doesn't say what error 2023 means, but it does have the phone number for a support line printed on it. Hi, you have reached weather machines and so on, Inc. How can I help you? You explain the situation. Error 2023, you say, why? That's a power overload error, of course. It means that you have too many components plugged in. Try unplugging some components, and you explain that there are hundreds of components here and you're in a bit of a hurry. Well, let's see how bad it is. Do you see a big red reset button somewhere? It should be on its own module. If you push it, it probably won't fix anything, but it'll report how overloaded things are. After a minute or two, you find the reset button. It's so big that it takes two hands just to get enough leverage to push it. Its screen then displays system overload. Connected components would require low power equal to at least 100 stars. Wait, how many components did you say are plugged in? With that much equipment, you could produce snow for an entire... You disconnected the call. You have nowhere near that many stars. You'll need to find a way to disconnect at least half of the equipment here, but it's already Christmas. You only have time to disconnect 3 wires. Fortunately, someone left a wiring diagram, your puzzle input, that shows how the components are connected. For example, this means that this is connected to those 3, right? That's just a graph. The name of the component, colon, and then a list of other components to which this component is connected. Connections are directional. ABC XYZ and XYZ ABC both represent the same configuration. But does this mean that we have both in the input? Doesn't look like this. So RHN is not going back to JQT. Maybe in the part 2 it will be the directional graph. In this example, you disconnect the wire between this, the wire between this, and the wire between these, and you will divide the components into 2 separate disconnected groups. Multiplying the sizes of these groups together produces 54. Find the 3 wires you need to disconnect in order to divide the components into 2 separate groups. What do you get if you multiply the sizes of these 2 groups together? Find the 3 wires you need to disconnect in order to divide the components into 2 separate groups. Let's take a look at the puzzle input. How big of a graph do we actually have here? Day 25. This is going to be day 25 input. And this is the example. All right. Also the timer to the next event. To the next game. All right. Sounds like a good idea, but if you write code to play the Tetris, does it continue running your bot forever? Like, how does it work? It looks like I cannot write it on my own PC here and test it in, like, write code in my VS Code, which will use annoying. Like, it would be annoying for me to write code in that editor instead of the environment that I'm used to. Also, you're only having JavaScript there and not Rust. So, not really looking forward to writing the Tetris player using Rust, using JavaScript. Black King, hello there. We are doing day 25 of the Advent of Code now. Just solved the day 24. Okay, let's see the graph. The graph is going to be basically a hash map from node into the list of other nodes, right? Where the node is a string, right? Sure, let's do that. Let's do arc string. Why not? So let's read the input first, which is going to be input lines map line. So we do name and connections is equal to line split once using the colon. So name is name into the arc, and then we say that connections is connections split white space map as into, because I'm converting this into an arcster, collect. So we do name and connections, and then we collect those into a hash map. All right, there you go. Let's debug the graph size, and let's also debug the number, the total. So like this is the number of vertices, right? Vertices is this, and edges is this. Iterate map values map edges length some, like that. Day 25. Part 1 example. So in the example we have 13 vertices and 33 edges. In the actual input we have 1000 vertices and 3,500 edges. There you go. Coding Game uses a web editor too. Yes, for that reason Coding Game is annoying. But yeah. In Coding Game you can run the game locally though. And the fact that it only runs when the tab is open is also getting your account credentials. Yeah, you could like make your own login API, like give every user a token and make the make it like a header with this token, for example, to logging in to the WebSocket like easily, regardless of what I'm actually using for logging into the website. But yeah. Okay. Whoops, hold on, I closed my Twitch chat. Okay, so what they are asking me of here is to try and find the three wires, so the three edges that I need to disconnect in order to divide the components into two separate groups. So I need to find two groups. Basically, we have a graph, which it looks like this. We have one connection and everything can be connected to each other here, kind of. And then we have another group, and we have three wires going in between. I need to find these three wires. I cannot iterate and try it. Any recommendation for Rust projects for beginners? Advent of Code? Like the first days at least, I guess. I don't know. Or if it's an actual project. I don't know. Just do whatever you like doing. Do whatever projects you are doing in other languages. I think. I started Rust with the game making and making my own game engine, because that's what I was doing in other languages before. Not sure if that's or just try solve the simple like problems like LeetCode or Advent of Code things maybe. What do you get if you multiply the size of these two groups together? All right. This is day 25 though, so this is mostly not about the programming, but just about coming up with a solution here now. What's the leaderboard say for day 25? People solved it pretty quickly, it seems. What about day 24 though? Day 24 was filled in an hour. Yeah, day 24 it looks like the hardest one. Okay. I don't immediately see the solution for this one though. Let me see. I can delete. I need to find the three wires. Hello, Brainoid. Hello, hello. Thanks. I need to delete three wires. But I have 3,000 of them. One thing that I'm thinking about is what if I like try and iterate over one of the edges and then I will only need two. With two it's kind of easy. Like if I only need to like delete one wire, for example, instead of three to divide into two separate groups, it means that like that we have a bridge in graph basically, right? Is what it's called. But when it's three, it's no longer a bridge, is the thing. If I try to delete one wire, like, and then see how do you find bridges? Anyway, I don't remember. Maybe we can use the algorithm for finding the bridges to find 2 of them. Oh, okay. Hold on. So if I choose one of the wires to delete, right, then this is the wire that was connecting the 2 things from separate groups, right? So we basically know 2 vertices, 2 nodes that are from separate groups. And now all I need to do is to find what are the edges that I must go through in order to get from the first node to the other node, right? Right? So let's see. I have deleted one of the edges. So I want to find, this is the vertex from the first group. This is the vertex from the second group, right? And we just find a path from this to this one. And like, regardless of what path we're going to go through, we are going to cross the boundary between the 2 groups. I guess at least once. There is 2 more. And to find these 2 edges. Wait, if I find a path that goes from this vertex into here and then goes back, then we will travel both, right? And we can do it because we can reach Is it possible that we after going to this one cannot reach that one? I mean, probably. But the idea here is that I've found the loop like this. It's not guaranteed that a loop like this exists, though. What am I trying to solve? Day 25 of the Advent of Code. Have you solved this one already? We have a graph with and we need to find 3 edges. The graph is undirected. We need to find the 3 edges that we need to delete. And after the deleting 3 edges, the graph should split into 2 connected components, basically. That's the entire problem here. We need to delete the 3 edges, and after that, we have 2 connected components. Is this a crab? Is this a crab? If you look, you have imagination, everything can be a crab. If it's not yet a crab, it will be a crab. Everything will be a crab. Now this is a crab. So yeah, and in the graph we have 1000 vertices and 3000 edges. So we can do it in quadratic time at most. So my idea currently is that we probably need to like just iterate over one of the edges that we're going to remove. And this will, since we remove this edge, it gives us 2 vertices from the different components that we need to get in the end. Kobe, look at me. I'm looking. Hi. The other thing that I'm thinking about is that once we have the 2 edges, like, so we need to find 2 more edges to delete. What I'm thinking about is to do the spanning tree of this, and it will help me somehow. I'm not sure. Am I winning? Of course. Not sure what, but I am. Not sure where, but I am sure. If I have a spanning tree, then I would be able to find the let's say that I have the path in between the 2 vertices, whatever, like any path at all, right? Any path at all. Any path at all is what I want to find. Any path at all will not be able to pass through both of these edges, only through one, right? So now that I have the any path at all, I will need to find another path. I don't have sure if I understand, but you need to know what is the star and the end of this edge on screen to draw the new one using a curve. Huh? No, 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 no. We have a graph. What? Did you read this? Let me read it to you again. We have a wiring diagram, which basically we have some components, right? And this component is connected to these three. This component is connected to these three. This gives you a graph. And then we need to split this graph into two graphs by deleting three edges. That's it. Not sure what's a star. And we're not drawing anything. We just have a graph where the things are connected with each other, and we need to delete three connections, which will split the thing into two things. I can let me do this. Graph viz online, right? So here's the example that we have, right? Here's the example that we have. Here's the example that we have. I guess let me work on this in the VS Code first. How does it work in? We do this. Add. Is this how it works? I don't remember. There you go. We have a graph, all right? So it doesn't really help me visualizing this thing though. But apparently, in this example, if we disconnect the wire between HFX PZL, so let's disconnect HFX PZL. I don't even see this one. Wait, what? Why don't I even see it? PZL. Oh, it's over here. Yeah, HFX PZL. Delete this. And then we delete the one between BVB and CMG. And between NVD and JQT. So if I do this, right? Then they told me it would be maybe the commas needs to be deleted. It's still weird. Did I not delete the things? Why is this still connected? Did they lie to me about the example? Do I not understand? Oh, it's just like the wrong format that I did? Oh, dash dash is the unconnected basically thing, right? So for the non-directional graphs. And then you also need the brackets. Okay, sure. Dgraph to graph 2. Line 4. I have a comma. Yeah, I had a comma here and here. here. Okay, there you go. There you go. This is a graph that we have. Well, I guess in this one we actually see it immediately. This is the edges that we need to delete, right? JQT, NVD, BVB, CMG, HFX, DZL. We cut these 3 lines, and they and the graph is split into 2 different components. It's like visible here. It is visible here. Easily. I also kind of see that if we delete these 3 lines, well, actually no, I was going to say that none of the 2 wires would be intersecting with each other, but no. This would still be intersection with this one. All right, whatever. Okay, anyway, this is what we're trying to do. And yeah, like I was saying, if I try to iterate over one of the edges that I'm going to delete, then I need to find 2 more. So I will find a path between the two guys here, right? And so we have 2 more, which means that this I think I need to find another edge that I need to delete. No, I don't see the solution here at all. Hi? Hi. Am I being like... Judging by the leaderboard, this should be a relatively easy one. But I still don't see the solution. You have a redeem that lets you know that Miggy is trying to get a hold of you. And why is it 3? Like, If it would be 1, it would be an easy one. I feel like. Maybe we just need to visualize this graph. You know, hold on. Maybe graph viz is the thing that we are going to do to solve this. Maybe that's how people solve this really quickly. By just visualizing the graph, and you will like because on this one we see the 3 wires really easily, right? So if I just do the same, but sure, let's go and print out. So we do graph, right? And then we do 4 vertex edges, and in the graph we print out the v dash dash like this, and then we do for I out in edges, enumerate. If I is not 0, then print the comma and print the out like this. Let's see. Here's my graph. Let me copy paste this. Let's just do this into copy paste to the clipboard like that. The only thing, the first 2 lines needs to be deleted. Cannot enlarge memory erase. Okay, it is a little bit too much memory for the graph viz, apparently. At least for the one online. Graph viz, it cannot be executed though. Nix shell graph viz. Graph viz. What is inside this package anyway? Bin. How do I use the graph viz from the command line? Dot. Okay. Dot v tsvg k nieto o j25 dot cannot open j25 dot. So I just do graph input dot. There you go. Do it like this, except for the first 2 lines. Input dot. Forgot the graph name. Does the graph name matter though? Can I make my VS Code show me the thing? Preview. GLTF. SVG. Can I show SVG inside the VS Code? Browser. Let's open it in browser, sure. There you go. There you go. This is our graph. You don't need the name. There you go. I found the solution. I see the solution. There you go. FDB, TXM. It's a beauty. Yeah. How to do this without graph viz though? Um, like, you did it this way too? This is cheating though. This feels like cheating. um, okay, but you can definitely see the solution on this one. Let me think about it a little bit. You did that way first and managed to solve it in code? Okay. Yeah. Well, I mean, there's a lot of edges here. GraphViz does, like, I don't know. How does GraphViz do it here? Figure out where the position of a thing should be, you know? You see two people and their hair tangled. um, does it work by doing like the physics, for example? Sometimes in order to visualize a graph, you just basically like spawn the nodes and then do like the soft body simulation kind of. So if the things are connected, they should be near each other, and then if they are not, they should not be near each other, and that would mean that the things are going to like go away from each other. But that's still not like simulate springs and pushes far nodes. Yeah, exactly. Exactly like I was saying it. If they are connected, they try to be near each other. The springs, you do the springs, and then if they are not connected, they try to be as far from each other as possible, basically. That's what I was thinking. We can write a simulation like this, but I don't know how to do it without the simulation, though. And this is also part 1. Is part 2 much different? Nah. Let's not submit it yet. Oh, there's only one part on day 25? Really? No spoilers? Day 25. Yeah, I didn't know that there was only part 1. Only one part. Hmm. It's always only one part. Yeah, but I never got to the last day anyway. I did it a little bit before of the advent of code. Oh, that's also a spoiler. If you say mean cat in chat, that also is spoiler. You just don't want me to solve this on my own. Alright, I see. Okay, fine. There's no reason for me to be thinking about it anymore. I don't remember what the min cut is, though. Max flow min cut. I remember a little bit, so like I said, wait, hold, but nah. I was doing it before. Yeah, this requires some theory knowledge. I can try remember it without looking it up even more. Can you do it without max flow min cut? Well, you did it by counting the heat of each edge. Well, it looks like, without looking it further, so we find the first edge, we iterated with the first edge still. So here's my first node, here's the second node, right? The max flow between this node and this node would be 2 edges, because like that's how much we can do, right? Kind of. And this is... Undirected graph, the smallest cut, 2 edges. Consider a pair of vertices as source and sink for the minimum. But so yeah, what I remember is that the best possible time complexity of the algorithm is OV to the power of 5, right? No, this is implemented in the V squared time, OE. Yes. So it is going to be E square complexity because we do the first cut to find the to find the S and T, basically the source and sink. While there are more than 2 vertices, pick a random edge in the contracted graph. Karger's algorithm? I don't remember this one. I don't remember if I did it at all at any point. Pretty sure I never implemented this one. I did the max flow stuff, but I don't remember doing the min cut myself. Pick a random edge, merge into a single vertex, remove self loops. The first randomly picked vertex to be A, which connects vertices 0 and 1. We remove this edge and contract the graph, combine vertices 0 and 1. Smallest number of edges that disconnect the graph into two components. This is like the exact thing that you need to do, basically. So the min cut without the max flow then. A simple solution, use max flow based STCat algorithm to find minimal cut. So this is not the max flow stuff. Huh? This can be implemented in this time. I don't get it. Hungerfall, hello. We just remove all the edges until there's only two vertices left. As what you do. Why does it work though? Why does it work though? And the order of the removal doesn't matter? Karger's algorithm. Is there a Wikipedia? So we remove the edge by reducing the number of nodes by 1. All other edges connecting and other reattached to the merged node. Effectively producing the multigraph. Karger's basic algorithm which regularly contracts random chosen edges until only 2 nodes remain. These nodes represent a cut in the original graph. With high probability. It says with high probability. It's not 100% then, right? It says with high probability on the Wikipedia. Success probability. Um, with n equal to the number of vertices, the contraction algorithm returns the minimum cut with polynomially small probability. Recall that every graph has this many things. For instance, the cycle graph. Okay, so it's not by repeating this algorithm this many times with independent random choices, the probability of not finding the minimum cut is very slow. Okay, so it is, they did not say that it is not like a guaranteed thing. You will find some cut eventually by doing this. You think it somehow contracts the large blobs on the left and the right into single node, and then the cut is the three edges. Yes, yes. So like, because there is a lot of, like, we just see this graph here, right? And there's a lot of edges here, a lot of edges here. So if I never choose these three edges, basically, right? If I never choose these three edges, but I merge all the other nodes together, then eventually I will end up with the first half being one node and the second half being one node. But it seems to me that, well, I mean, this is the probability that you have here. 1 divided by n is the probability of not finding the cut. So there is still a probability. What am I learning? I am learning the min cut algorithm, the Karger's algorithm, which is the randomized stuff, to find the min cut of a connected graph, which we need to use to solve day 25. I know that you can do the minimum cut using the max flow algorithm, but max flow would run a lot slower from what I understand. Max flow min cut theorem, 2 nodes, minimum cut is minimum cut value is equal to their max flow value. In this case, some algorithm using in the max flow could also be used to solve this problem. So max flow min cut is the thing that I remember. But for that you need the source and the target. And it's more complex algorithm. Advent of code based on algorithms like LeetCode. Yeah, kind of. Do you need to build a staircase up or down in the dig world? You don't need to do anything. Are you trying to play the dig world? Is it still online though? Hold on, let me see. Dig world. Is it still online? Let me see. I guess you are playing the single player version. I think my server is down. This game had multiplayer in it, so I could show you, but that was the entire idea. It just I'm not even connecting to the. I'm not even trying to connect here. It seems. What? Whatever. You play offline. Yeah, it's just a sandbox, a very simple one. It was made in 2 days, so there is not a lot of goals there. You just dig down, collect the treasures, give it for money, get the letters. There is nothing in the world, except for the things people would build on the server. Yeah, that's it. Very simple game. There's not much. Okay, well, let's implement the algorithm of the Kruger then. Sure. Sure. Um let me do it Advent of Code, did you win yet? No, it's day 25. Unfortunately, I was a little bit spoiled by chat. I heard the meme cut, so yeah. But day 24 though, I did it without math. I did the I did the random search. You did 2025 without code? Yeah. I mean, I'm there too. I'm there too. But I want to do it with code. Okay, so we just need to find the min cat, and there is an article over here. This is what we're going to do. The algorithms. There is also the store Wagner algorithm. What is this one? Recursive algorithm to solve the min cut problem in an undirected graph with non-negative weights. It was proposed over here. Card is a partition. What's the complexity of this one? A single run is this. So overall, it would be something like this, which is okay. This is the good complexity. Hold on. So this is not the RNG algorithm. Use your algorithm. What's your algorithm? Let this be a weighted undirected graph. Suppose the cut is called an ST cut if exactly one of S or T is an S. The minimal cut of G is so that ST cut equals the mean cut. The algorithm starts. If I find an S and T in V and a mean ST cut, mean cut for any pair ST, there are two possible situations. Either ST is a global mean cut of G, or ST belong to the same side of the global mean cut of G. Therefore, the global mean cut can be found by checking the graph GST, which is the graph after merge vertices. During the merging, if S and T are connected by an edge, then this edge disappears. If S and T both have edges, what? The algorithm works in phases. I don't understand anything that's written here. This is... Who wrote this thing? While number of groups less than 2, cut random, cut random, cut random. That's the... that's not your algorithm. That's the Karger's algorithm. That's what's it called. So there are multiple ways to do the min cut. One of them is this RNG stuff. Stole it from you, okay. And another one is the store Wagner. The algorithm works in phases. In the min cut phase, a subset of A of the graph vertices grows by starting with an arbitrary single vertex until A is equal to V. In each step, the vertex which is outside of A but mostly tightly connected with A is added to the set A. The procedure can be formally shown as this: sum of weights in a single phase. So we grow the one that's most tightly coupled. Okay. What is the best way to learn Rust? Read the Rust book. I don't know. And write something that you want to write. By writing code. And reading the book. For store Wagner. I can see what Oh, 11 minutes though. Eh,
A cut C in the supernode can vertex
too much.
and in each problem from the minimum cut.
Too much. After n-1 phases, the minimum cut can be determined. Doo-doo-doo. So, how do you start a subset A? You start with any vertex, I guess. The minus run out of meaning cutting phase. What is A? Minimum cut phase, GWA. Minimum cut, GWA, while B. What is A? A is some starting vertex that, like, I don't get. They don't describe it in the algorithm here. What is this? Randomly select nodes 2 as the starting node. So, like, it is still a random one? Like, I guess it doesn't matter. What you start with actually here. And then in each step, you you grow your set by the mostly tightly connected one. If the cut of the phase is lighter than the current minimum cut. Oh, okay. I see it. I can see the algorithm working. So here's I think how it works. So we start with a random vertex. It doesn't matter which, right? So let's say this one, right? Then I find another vertex which is connected to this one. And then I have two vertices. I guess it doesn't really matter. Wait, but it can happen that I like go there then. So, but basically, yeah, basically we are going to like grow from one vertex until we have the entire like component here by choosing the next vertex to add to our like current set. Which is like deleting the most amount of edges, I think. And then eventually we grow up to this thing, and then we start growing into the other thing, basically. So somewhere while we are growing in the middle, we have our current set and all the other. And the min cut is basically the number of edges going from the current set to all the other edges, basically. I can see it in my head, I think. Seems like the Kargar's algorithm is much simpler though. Let's do this one. This one is very simple, I think. The hardest part is making it like running optimally, I guess, right? So this will give me, what do I need to do in this one anyway? Sizes of these groups. I see. Sizes of these groups. So yeah, this will give me the two groups with their sizes. There you go. Yeah. Over here we have a graph. Graph is a hash map from node into the list of nodes. Just like that. And we return the sizes of two components in the end. So there you go. We just do it a bunch of times, right? Loop. We find and in this problem specifically, we need to find the one that cuts it using 3 edges. So let's see. We just choose a random edge, basically. Edges is a vec of the edges. So 2 vertices that I'm going to join together. By the way, this graph is undirected, so I need to make sure that you know what? Let's do the graph. Let's do the graph differently. Let's do the graph as just the list of edges. So edge is just 2 nodes. There you go. That's a much simpler representation of a graph. There you go. So it's going to be graph into iterator, app, node and edges. It's going to be flat map, edges, edges, into iterator, app, u, v, clone, and u. There you go. So our graph is going to be a vec. Use an array here instead of a tuple with so the node is argstring. 2 nodes we connect together into a vec. There you go. Okay. So we literally just choose the random one from there, right? Hmm. So the edges that I still have. You deduct to the end is now falling? Yeah. That's how it works there. Guess I just do this. I need to be able to clone the node. There you go. So this is the edges that are still in the graph, basically, I guess. So we just do the number of vertices is going to be equal to g iterate flatten, and it's not an iterator. This is a list like that. Okay, so this thing collect into a hash set. Length. This is just like the number of different vertices in the graph, right? That we start by every vertex being its separate vertex, basically. So then we do while we have more than 2 vertices, right? We choose a random edge. Random edge is going to be we generate the range from 0 to edges length, and then we do edges swap remove from this index, so that we just choose a random edge and we remove it. And this is 2 vertices A and B that I need to merge, right? Right. So these are the 2 vertices that I need to merge together, right? And then in order to merge them efficiently, we use this stuff, disjoint union set, right? Disjoint set data structure. Union find data structure, merge find set, the data structure that shows a connection, a collection of disjoint sets over non-overlapping sets. We just have the parents for every node, like what is this node connected to? Stuff, right? Hash map from node into node. Yeah, so I merge these things together. The only thing is who is becoming the parent here, and I think you just do it randomly here. Thread RNG generate the boolean. Just generate the boolean, and A and B is either A and B or BA. So we randomly choose who is becoming the parent when merging the nodes together. Let me make this separately here. Struct DSU parents hash map and n. There you go. DSU for the nodes which are hash and clone and ec. Sure. This is what I need. Why can I not import std hash? Whatever. I mean, I can, but the rationalizer doesn't want for some reason. So we have the function merge A and B. Also frustrated that it couldn't find hash automatically. That's the only thing that for some reason cannot be imported automatically by the Rust analyzer. I wonder what's the reason. So yeah, just randomly connect either A to B or B to A basically here. I will also need to figure out the parent of a vertex. So yeah, I just say that self parents get for the vertex. So I just need to find the root here. I guess root is self root for this. I guess I'm going to match here. If the parent, if there is no parent, then it is myself. If there is some parent, then I do self root for the parent. There's a bug for it. Nice. Nice. To cloned here. Okay, so here we go. We find the root, and then I just need to make sure that parents insert. I guess if root is not equal to this, then self parents insert for v the root. So we're like reconnected directly to the root, and then we return this. There you go. And then when we merge things together, I see that if the root of A is not equal to the root of B, I mean, I just connect those roots together. I just say that A is self root A and B is self root B. So if those roots are different, means that they were in a different thing. If A is not equal to B, then self parents insert for A to B. That's it. Linksider is very good. Linksider is the game that we're going to make into a full game. We are continuing to work on it. That's the best game I have so far. So sometime next year, hopefully we release a game, the Linksider. There you go. This is just the merging stuff. So we just do over here, DSU is DSU new, and then I just DSU merge A and B. There you go. There you go. And the merge should return a boolean if it was merged or not. So over here, if they this means that they have been merged. Otherwise, they were already like basically the same node before. So I just say that if we did merge, then vertices minus equal 1 because we have actually done the merging. There you go. And then the amount of edges that are left is edges. We figure out the A and B DSU root of A is not equal to the root of B means that those are in the different things. So if they are in different things, then this is the count of edges that are actually left. So if edges left is equal to 3, then I return the number of the sizes here to the left and to the right. Right? Yeah, I think so. So components that are left is so this is all of the vertices. Let me just do it manually here. Hash map new. So I do 4 vertex in all the vertices in the graph. I say that components entry for the DSU root of this vertex. I add one more vertex into this component, right? So I just do components. I convert this into values. You get just the sizes now. And then I collect those values into a vec. And then I convert the vec into 2 because I need to have exactly 2 sizes there. Try into unwrap. And this is something that I return. There you go. Right? So is this the entire thing? And we just do it in a loop. And eventually we find the solution because this is RNG. Right? So let A and B is Kargar on the graph. Right? And then answer is A multiplied by B. And we print out the answer. Okay, is this going to work? Cargo run. Part 2 example. Closure may outlive. Yes, I need to move here. There you go. So the answer is 1053. Multiplying the size of these groups together produce 54. Okay, I did find something absolutely different. Let me debug this, I guess. I have 2 components with 39 and 27. I don't even have this many vertices. Wait, what? Hold on. Let's debug the components here. Let's debug. Number of edges. Maybe I'm storing something different here. Components should be like hash map from node into the numbers. I cannot import the std_fmt debug too. Hold on. What? std_fmt debug. Fuck. These have moved value components. I'm using example. I'm using the example set. Let me show you here. Debug the graph itself. So here's the graph. Here's the graph. It looks like I did it multiple times. It did not find the solution on the first try. This is the graph, pretty small, right? Pretty small. Let me over here print out what is in what component. So vertex V goes into this component basically, right? Okay, well, I only required the debug because I did this generic way. Consider cloning the value. Over here, let's clone, sure. Okay. So this is all the different vertices, which seems like I have a lot more here. Oh, wait, hold on. I know why. It's because like I'm iterating over all the edges here, but I need to iterate over all the different vertices. There you go. Because in the list of edges, all the vertices, they appear multiple times. So I need to collect this into a hash set again. Right? Of nodes. There you go. This is like, let me do this all nodes. All nodes is this, and originally the number of vertices is all nodes length, like this. There you go. This should be much better. So now the answer is 54. There you go. There you go. And now we just run this on not the example, but the actual data. And here's my answer. All right. This is a simple algorithm. Continue to part 2. Part 2. You climb over the weather machines under giant springs and narrowly avoid a pile of pipes as you find and disconnect the 3 wires. A moment after you disconnect the last wire, the big red reset button module makes a small ding noise. System overload resolved. Power required is now 50 stars. Out of the corner of your eye, you notice goggles and a loose fitting hard hat peeking at you from behind an ultra crucible. You think you see a faint glow, but before you can investigate, you hear another small ding. Power required is now 49 stars. Please supply the necessary stars and push the button to restart the system. You have enough stars to push the big red button. And you supply all 50 stars and restart global snow production. As you reach the edge of Snow Island, you can already tell from way up here that everyone will have a white Christmas this year. After all, congratulations, you have finished every puzzle in Advent of Code 2023. I hope you had as much fun solving them as I had making them for you. I'd love to hear about your adventure. You can get in touch. If you'd like to see more things like this in the future, please consider supporting. To hear about future projects, you can follow on Twitter or on Mastodon. There you go. Once you understand it, it might seem simple. I've seen others struggle to understand and implement it. I haven't tried yet. I think the only thing that is a little hard to understand is to figure out the disjoint set data structure that I have implemented there. That's like the hardest part. But this only is required to make it run a lot faster, so that amortized time is ON, right? But even without this, you can make it you can make basically like a cubic complexity without this data structure. The Kargur algorithm itself, I think, is pretty easy. You did a BFS from each node and counted how many times each edge was used. Yo, thanks for the bits. How many times the edge is used? In the shortest path between all the two vertices. That's a funny thing, right? Yeah. because those that are in the min cut, those like basically have a lot more chance to, like, one of those three edges are guaranteed to be on the path, right? Yeah, so for that reason the relevant edges are used more than others. Yeah, it makes sense. It's a funny solution. All right. Okay, I think I could have came up to this eventually myself, even though we did get a little spoiler that this is about the min cut. I've seen min cuts before, but not this algorithm. But I did do the DSU. All right, there you go. The advent of code is now done, so we can go back to doing other things. So we usually do the game development. The Linksider is the game that we're going to continue making. It's a puzzle game. Not today though. Today I just wanted to finish the advent of code. This is the old version. And we have a much better version. Already there. I know that Davey did something for the game. I guess we check it next time though. It was a short stream, but I think it's enough for me for today. So yeah, next time we go back to Linksider. Not sure if it's going to be in December, or maybe that we start working on Linksider in January. Anyone still doing Advent of Code? No, no one is doing Advent of Code anymore. All right. Well, here's some Rust then.
Okay.
You guys, next time. 5, 4, 3, 2, 1. Bye.